Okay, so to conclude this section, we'll just open the 10D Fanuc training dispensing. So here, this one here. So what we did so far was just following some paths that were straight on a table, but we can also obviously do the same for 3D sketches or 3D paths. So here I have a few examples for you. So the first one being a 3-axis path. So we're just following XYZ, but we're always keeping the dispenser normal to the path. So if I run this one here, oops, I can run this one here, apply some sealant around the path here. So that's great. If you can notice here, if I go back just a bit, oh yeah, there's a pause. This is why it's stopping here. There's a small pause because I'm generally using that to record some small marketing material, and I always add a small pause so that I can close stuff, remove my mouse before the actual program starts. So you can see here, I'm really like keeping my tool aligned with or normal to the floor, perpendicular to the floor. So that's one method. If you have, I'm gonna hide this one here. You can also do the same with some 5-axis paths. So no, those are normal to the surface at all time. So if you can see here, those normals are straight up, but as the 45-degree angle appears, we have kind of a curve that draws itself and then go down. So the curve here is just composed of a bunch of small linear motion, but the same way your computer has square pixel, it can still draw line or draw curves. That's the same exact concept. So if I was to run here, this one I'm going to remove the 4-second pause here and just run it. This time it will rotate like that. So it's following, it's just keeping the tool normal to the surface at all time. So that's just something that I want to show you that we can do. We're going to learn how to extract that kind of path in the next few tutorials. One last thing I want to show you though that is really different this time. Something that will potentially happen to you if you extract a path. You will have a path like that, which is the 3-axis path, but you will see some gaps in the path. So there's a gap here, there's another gap here, and if you were to just run it normally, if you were to open the curve follow project and have it like in a normal state where approaches retract each curve is activated, you would see those approach and retract at each gap. So that can be problematic. The easiest way of getting rid of those is to select approach and retract each curve. This will simply create a straight line in between, but that's not always exactly what we want. So let's say that we have, I'm gonna simply take that piece here and delete that piece of curve here. So let's say that I have here select curve, I'm gonna select that, reverse direction, and auto select all, click done. Let's say that I have that here. So if I update, why? Okay, visible toolpath. Okay, that makes sense. Visible toolpath was not activated. So if you see here, it will bridge the gaps in the path, but it will also bridge the gap here, which is not necessarily what I want. Potentially here, what I wanted to have those paths bridged, those gaps bridged, sorry. But here I would like to have my approach and retract. It doesn't make much sense in this example, but I'm pretty sure you understand what I mean. So if you were to click approach and retract each curve, it would create our approach and retract that we want here, but it would also create approach and retract everywhere, which is kind of problematic. So this is where joint curve tolerance comes very handy. This is a way to tell RoboDK how much of a gap you accept in a line for it to be considered as a straight line. So by default, you have 0.5 millimeter, which is kind of small. But let's say if we enter 5 millimeters here, it will do the trick. So every gap here is less than 5 millimeters. So if you see a gap that is 5 millimeter or less, just consider that it's a straight line. And if you see a gap that is more than 10 millimeters, like this one here, just apply the standard approach and retract motion. So if I was to run that here, and this way I'm not losing my let's say activation of my glue dispenser or sealant dispenser in this case, and I'm doing my bridge or my gap, and then I'm restarting the dispensing. So yeah, that's just a little thing that I wanted to show you so that you are aware of that. That can be super useful in certain situations. In fact, save you a lot of looking around and not understanding time, if I can say. So yeah, so I hope you enjoyed this section. In the next section, we'll start exploring how we can actually create those paths, because since we started with the advanced path generation, we were just like kind of clicking on lines that I imported, but that's not always how things work. You often need to be a bit more, in fact, you need to bring those paths to RoboDK in the first place if you want to be able to use them. So we're going to learn how to do so.